Good evening to everyone. Today we're going to talk about estrus cycle, pregnancy, parturition, and puerperium in the cattle. So, first of all, we're going to talk about the anatomy of the female reproductive tract. So, to start, the female reproductive the tract starts with the vulva, and then we have the blind pouch, the bladder, where it's like where you have the urine. Also, we have the vagina. Then we have the cervix, and after that we have the uterus, and then we have the uterine cords. Then we have the oviduct, and at the end of all, we have the ovary. So we're going to explain all the process that occurs during all these process of the pregnancy in the cow, and also with the cycloestrus and these kinds of hormones that are going to be released by the uterus or by the ovary or some organs. So okay, we're going to start with this.
Well, and before speaking about the estrous cycle, it's very important that the animal, in this case the mare, has reaches the puberty. Puberty is when the animal has the physiological maturity to produce the gonadotropic hormone, the gonadotropic releasing hormones. And this means that the hypothalamus and the pituitary has to be mature enough to produce these hormones. And once the mare has reaches puberty, we can explain about the estrous cycle. Well, the estrous cycle is divided in two phases, which is the follicular phase and the luteal phase. And the follicular phase starts with the with the with the with the with the proestrus. Proestrus, we could say that it starts when the corpus luteum is destroyed of the past cycle, and it ends when the mare is receptive to the bull. This phase is characterized because the level of estradiol, which is an hormone that is produced in the ovule, and it is increasing. In this follicular phase, the follicles is developing and they are increasing, and at the same time the level of these hormones increases. And the proestrus every time the follicles start increasing, they reach a critical level, a critical point, which is the which is a critical point of the estradiol, and and this critical point makes a process called preovulatory of LH, which leads the ovulation. And before this preovulatory ovulation, the animal went has to pass by a process called which is the other phase called the estrus, that starts when the animal is receptive to the bull, and it ends with the ovulation. And this phase is characterized because the mare shows some symptoms of this estrus, which are maybe the cow stop eating, they stay tense for minutes, they leave the other cows and they leave other cows to jump on them, and there are a lot of symptoms that we could mention. And again, the estradiol is the hormone that is dominant, and in the pre-ovulation of LH in the mares occurs at the end of these cycles, but in other animals, the this ovulation occurs at the middle of the estrus. And here we can see the different hormones that plays this different roles in these cycles, and the well the well speaking a little bit more of the proestrus, and this when the proestrus begins, the follicles starts increasing from 6. There is a process of selection in which from 6 the follicles end up with 4, then with 3 and 2 until we end up with 1 follicle that is dominant and is called the Kraft follicle. This Kraft follicle will just ovule with 1 oocyte. Reaching this ovule will reach a level of estradiol, like I said, to start the estrus, and as I said, is when the animal is receptive to the bull.
Okay, so two of the other stages is the estrus and the diestrus. So first of all, we have to know that the estrus cycle is around 21 days. So after the ovulation, the membrane of that have the ovary, it's called like a yellow body. So then the luteinizing hormone comes into this yellow body and make it as a corpus luteus. So this corpus luteus starts to produce the progesterone, or P4, that is right there. It's the progesterone, and this hormone is really important to maintain the pregnancy of the cow. So if the cow gets pregnant, it's going to maintain the hormone progesterone P4 until the parturition. But if not, then the uterus produces a hormone that is called the prostaglandin F2 alpha. So this hormone, what it have to do is to destroy this corpus luteus in order to decrease the level of the progesterone, and then start again all the cycle with producing the gonadotropin releasing hormone, and then again producing the two gonadotropic hormones that are called the LH and the FSH. The LH is the luteinizing hormone, and the FSH is called the follicular stimulating hormone. And after that, also again comes the cycle of increasing these follicles, and the follicle, what happens in there is a liquid of hormones that are of estradiol, and then that's all the process. So now we're going to continue with the next step. So what will happen if the cow gets pregnant? So what is going to be now is that there are two kind of ways that the cows get pregnant. One is by the natural process, that is when the bull comes and leave the semen in the vagina, and the other process is by the by the artificial insemination. So the first one, the natural process is that the bull is going to jump into the cow and is going to introduce his penis from the vulva to the vagina, and is going to release the semen right here before the cervix. So after this, the spermatozoid is going to travel from the start of the cervix, and it's going to go around until it goes until the oviduct, until the ampular isthmic part of the oviduct, where it's going to encounter with the ovule that is going to be released by the ovary. So what happens with the spermatozoid? The spermatozoid, when it starts to travel until the cervix, will have an immediate transport, retrograde loss of phagocytosis enters into the cervix, and then here we have the first filter of the spermatozoids, because the cervix have like these these cervical crypts that are here are these ones. So some spermatozoids are going to stay in some of these crypts, and that's one of the filters. Then they are going to arrive until the uterus. So in the uterus, they're going to have a capacitation that is going to be explained, and the spermatozoid is going to have some change in order to get onto the in the structure of the spermatozoid, and in order to get onto the oviduct part. So then they're going to pass onto the oviduct with capacitation completed that goes around 10 hours, and it's going to be an hyperactive motility. Then they're going to pass from this oviduct, and we have here the third filter that is called the endometrial crypt. So this endometrial crypt, it works the same as the cervical crypts. And then they're going to wrap to the ampular isthmic part of the oviduct, where it's going to, again, as I mentioned, it's going to encounter with the ovule that have been released by the ovary, and they are going to occur the syngamy. That is the process when the spermatozoid and the ovule fusion. So now I'm going to explain what happened with the. So here we have the three parts that are going to be the stages of the spermatozoid. So the first stage is the epididymal. That means here is how the spermatozoid is going to be when it's in the testicles of the bull. And then after it has been released or ejaculated in the vagina of the cow, it's going to be as this, because here the spermatozoid have a liquid that can give him some energy and some proteins to survive. And then we have then the capacitated spermatozoid that is going to be in the uterus, that, as I mentioned, was around 10 hours. So then when it encounters with the ovule, what happens is that the spermatozoid is going to attach with the ovule, and they're going to fusion their membranes in order to, because we have to take into account that the ovule and the spermatozoid are two haploid cells. So when they attach, they are going to form a diploid cell, and they're going to start all the process of the mitotic mitotic division. So here we have like the two ovules, they have been attached. The membrane is going to disappear, and then here we have the nucleus of the spermatozoid that is going to fusion with the nucleus of the ovary. So we're going to talk now about the pregnancy part.
Well, I'm going to talk about the pregnancy, about the pregnancy stage of the cow. First of all, we have the oocyte and the spermatozoid, and then the fertilization occurred in the ampular isthmic part of the oviduct, and then we have the oocyte, that are the two nucleus of the spermatozoa and the oocyte. So then the two nucleus get fusion, and then we have the zygote, that then it start to multiplicate, and then we have the two-cell stage, and it continue multiplicate until we have a morula. That it's morula is like is compound of 16 or 32 cells, and then we have the early blastocyst, and then it gets out of the pellucid zone, and we have the Hashten blastocyte, and then finally we have the Hashted blastocyte. Well, then we have the ECM, that is the inter-cell mass, and then we have the blastocyst, and then the ICM is gonna transform into an embryo, and then we have a mesoderm and the primitive endoderm, the blasticle, and the trophoblast. Then the mesoderm is gonna get bigger, and then we have the blasticle get into a yolk sac, and we have the trophoblast, the down part of the image, and then we have in the third part we have an amniotic pulse, and then we can see that the mesoderm is getting bigger and the yolk sac is getting little. So then in the other part, the trophoderm and the mesoderm get fusion, and then we have something called chorion, and then we have it's getting a new stock called allantois. The allantois is getting bigger and the yolk sac is getting little. So finally we have the embryo that is gonna keep increasing of size, and we have the amniotic and the fusion of the trophoderm, the mesoderm, and the allantois is called allantochorion. Well, we have two types of placenta. One is called concave, and the other is called convex. The convex is in cows and giraffes, and concave is in sheep and goats, and in mares too. I'm gonna talk about the difference, or why it's a convex placenta in a cow. Is because when the chorion tissue and the cotyledon get close, get fusion, then we can see the convex form of the placenta. When, like my partner said, the progesterone is the hormone that is the one that keeps the pregnancy. So the luteinic one is producing progesterone, but it's not enough progesterone to keep all the pregnancy. So the placenta the placenta keeps making more luteinic bodies, and it's producing more progesterone. The placenta, the progesterone made by the placenta is the one that is gonna be in all the process of all the pregnancy. Well, then my partner is gonna talk about the parturition.
Well, we're talking about the parturition. It is simply the period after the cow had born, give the little born the it's when the cow is suitable for returning for sexual activity. The ovarian activity restarts, ovarian activity restarts, and uterus recovery is secretary capacity. Well, talking about the puerperium, the partition, it's when the fetus is already ready to go out from the pregnancy. You can say when the fetus is ready, they start like giving a signal to the cow pregnant that is a chemistry signal that is the fetal cortisol. That the fetal cortisol is like with help of with enzymes, it's with the E2 it yeah, it's like level up the pneumatical contractions, which then make or level up the pressure and pick up the cervical stimulation. After that, it's with the hypothalamus, it's release the oxytocin. That is the oxytocin that will be relaxing the 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 tract for the cow. Then the PGF2 alpha will be doing a process of glucolysis. That is when the gluteus rat boy is destroys. Then it's have part of relaxing. The pelvic ligament stretching, like it almost like relaxing to the tract to be like in order to have a good burn to it. Yeah, the puerperium, as already said, it had to be completed. The puerperium had to be complete. And how it completes? It completes about with two steps. Or phase or step that is to returning to ovarian capacity and returning to the glandular capacity, in which in time it lasts in or it have a time to 21 to 28 days in a mid cows, 28 to 35 days in mid production of cows, and 21 days in goats. It has to get to the conception. It will be have a uterine involution. That is another step. That is with the hand with this new or handle with the retrieving to ovarian capacity. It consists in reducing the uterine size in length and diameter. Second one is reducing the uterine volume. The third one is the expulsion of lochia. And last one is endometrial repair that will be that will make the cow with capacity to have a condition to have a new pregnancy. So that is all the process.
So it's really important to know that all this process, beginning from the estrus cycle until the cow has given the birth of the new neonate, and to know when you have to inseminate or to make it to have the second service of the cow, because in all these kind of agronomy related with cattle, you need to produce around one neonate each year. So if you don't know all this process and all the time that it takes around of the cycle estrus and the signals that the cows produce when she is in heat, and you don't know when is the time to inseminate the cow, you're going to lose a lot of money, because you're wasting time, and time, in other words, is like converting all this in money. So making a summary of all of these of all this process, we have to take into account that first of all we have this estrus cycle that is divided in two phases: the luteal phase and the follicular phase. And also this estrus cycle is around 21 days. And also we have to, after that, the estrus cycle is divided in the proestrus, the estrus, metaestrus, and the diestrus. And also it's really important to know all the hormones that are produced in all of this cycle. That is the estrogens that it's called estradiol E2, the progesterone that is called the P4, the prostaglandin F2 alpha, and also many hormones that I'm going to explain in later. So there are two ways. If the cow is not pregnant with the semen of a bull or by artificial insemination, then the estrus cycle is going to be repeated. If not, then it's going to have the process of, for example, the corpus luteus is going to stay there. The prostaglandin F2 alpha is not going to act on destroying it. So thereby we're going to have a lot of production of progesterone. That, as I mentioned a lot of times, it's really important to maintain pregnancy, because if in the case that the hormones could be altered, the prostaglandin F2 alpha is going to act over the corpus luteus, and then it's going to be reduced the amount of progesterone P4. Thereby, the cow is going to expel the fetus out of the tract, and that is what we don't want that. So after all these the conception, what happens with the spermatozoid and the ovule that have been released? Both of these are going to join together. The membranes are going to fusion, and also the nucleus of each one of the haploid cells are going to be fusion again. So we have many stages from the conception. So when first we have the oocyte, then the oocyte, the two pronucleus of the haploid cells join and fusion. They are going to form a zygote. This zygote is going to start dividing in the inner of that cell, of the diploid cell, until it reaches around 16 to 32 cells, and this is going to be called the morula. Then the morula is going to have the first differentiation of the cells that is going to be divided on the inner cell mass and also the trophoblast cells. The trophoblast cells are going to produce the placenta later. After that, they are going to be produced the amniotic sac and also the allantois that are going to help the embryo, and also the inner cell mass is going to convert into the embryo. So What does the I forget to tell you this, that after it converts in the morula, it has the first differentiation. The It's going to convert into a blastocyte, into an early blastocyte, and then it's going to have a process of hatching that is going to be out of the pellucid zone, and then it's going to occur all this process I mentioned, and then after that, this early blastocyte is going to travel freely around the uterus. So this blastocyte needs to go around the two uterus horns in order to have a maternal recognition from the cow. Because if they don't have this maternal recognition, the prostaglandin F2 alpha is going to be released. Thereby, there's not going to be a development of this new embryo. So this occurs around the day 12 and 14, and also the embryo needs to go around 12 to 14 times around the uterus, around the uterine horns, in order to make this maternal recognition, and it takes around 8 hours to make all this process. So after that, the embryo is going to increase, and then when it is time to make the parturition, the placenta is going to make another process. As my friend said about something about the placenta, important fact is that the ruminants have a cotyledonary placenta, and exactly the cattle and the giraffes are going to have a convex cotyledonary placenta. Why? It's because the cotyledon of the placenta is going to fusion with the chorion with the maternal chorion, and these two are going to make a placentoma, and this placentoma will have a convex form related with the chorion. That's why these cattle have the cotyledonary convex placenta. And the smallest ruminants, for example, the goat and the sheep, they have a concave placenta. So when the fetal has reached the point until it converts into a new neonat, and it's going to be the birth time, the neonat is going to be stressed, thereby producing a fetal cortisol. So what is going to make this fetal cortisol? The fetal cortisol is going to act with the progesterone, as is here, with the progesterone, the P4 of the placenta, and with the enzymes, it's going to be transferred to the estrogen or the estradiol E2. So this estradiol E2 is going to lubricate, is going to cause a chemical reaction, and is going to secrete make a secretion in the tract, obviously of the female tract, and this lubrication is going to help to the neonat to be birthed, for the born of the new neonat. And also the estrogen, the estradiol, is going to cause myometrical contractions. Thereby, there's going to be a cervical stimulation and a cervical pressure. And this cervical pressure is going to give signs to the hypothalamus, and the hypothalamus is going to produce a new hormone that is called the oxytocin. And this oxytocin is going to cause a maximum pressure in order to the neonat to go out, and also to make bigger all the female tract. Then it's also produce the fetal cortisol is going to produce the prostaglandin F2 alpha. And as I mentioned at the start, this prostaglandin F2 alpha is going to destroy the corpus luteus. Thereby, if there is no corpus luteus, there is not going to be more P4 or progesterone. And thereby, this process is called luteolysis. And also, the prostaglandin F2 alpha is going to give another hormone that is called relaxin, and this relaxin is going to make a pelvic ligament stretchment. So so the female, the mother is not going to like suffer a lot with the contractions and with the pass of the neonate by the tract in the vagina. So after this, the new neonate is going to born, and then we are going to have we're going to have the first lactation, that is called colostrum, and this colostrum is really important for the neonate, because it contains all the defenses that the neonate needs. So it's really important that the neonate takes in here this colostrum around 4 liters in the next 12 hours. So after that, in the neonate has been born, there's of course another process that is called the puerperium, as my friend was telling you. The puerperium. Next. The puerperium is the part where the uterus is going to reduce until the normal size before it has been pregnant, and also the volume and the lochia and all the placenta and all this is going to be a expulsion of the lochia and also an endometrial repair. So we have to take into account that this puerperium is going to take around 21 days, also at the estrous cycle. And the first cycle, the first estrous cycle that is going to be present is not going to give any signals in the cow. After that, we're going to arrive until the second cycle, and the second cycle is not so good because it has not 100% of fertility. Then, so we have to wait, and we have to wait until the third cycle, in which we are going to make an insemination or make the bull put the semen on the cow. So the third cycle is the indicated, and so we have a time that we have to wait, that is around 16 days until 72 days. So we could have a new conception. So we have to take into account another thing that is important is the nutrition of the cow, because the nutrition of the cow is going to be related with the hormones that is going to be released in all this process, with the different nutrients that they're going to have, for example, phosphorus, magnesium, and calcium. And also, it's important for the fertility of the female. And also, the nutrition is really important for the male, because it is really related with the spermatogenesis. And in the semen we need more spermatozoids that are going to be alive when they arrive to the vagina before the cervix. So, well, all this process is really important, as I mentioned, because we need to have around 1 bird per year in order to increase our cattle. And that's all for us. So thank you very much.